Around 107 new submarine cables totaling over 400,000 kilometers were deployed from 2016 to 2020, with a value of over $13.8 billion. According to Telegeography, there are currently around 450 fiber optic submarine cables carrying communications under the world's oceans. This map indicates where some of these cables are currently run. You can see a lot of them running from the United States to Europe, and then again from the west coast of the United States all the way over here into the eastern parts of Asia and all around the world. All of these lines are all cables. According to Telegeography, there are currently around 450 fiber optic submarine cables carrying communications under these world oceans stretching over 1.2 million kilometers or 0.7 million miles. Optical fiber has several properties that make it more desirable than copper wiring. Optical fiber is immune to electrical noise, has a higher bandwidth than copper, and light traveling across fiber does not attenuate as much as electrical signals traveling across copper. However, copper wiring is less expensive, where the ends of an optical fiber must be polished before they can be used. The installation of copper wiring does not require as much special equipment or expertise as optical fiber, and copper wires are less likely to break if accidentally pulled or bent. IR, infrared, is a form of electromagnetic radiation that behaves like visible light but falls outside the range that is visible to the human eye. Infrared wireless technology is used in intrusion detectors, home entertainment control units, robot control systems, medium range, line of sight laser communications, cordless microphones, headsets, modems, printers, and other peripherals. Like visible light, infrared disperses quickly, and these signals can reflect from a smooth, hard surface. An opaque object as thin as a sheet of paper can block the signal, and as does moisture in the atmosphere. Infrared communication techniques are well suited for indoor spaces where the path between the sender and receiver is a short distance apart and free from obstructions. Infrared is classified as providing point-to-point communication and allows computing devices to communicate via short-range wireless signals within about a 30-degree line of sight. With infrared, computers can transfer files and other digital data bidirectionally. The infrared transmission technology used in computers is similar to that used in consumer product remote control units. Other point-to-point communication technologies also exist. One form of point-to-point communication uses a beam of coherent light produced by a laser. Laser communication follows line of sight and requires a clear, unobstructed path between the communicating sites. Unlike an infrared transmitter, however, a laser beam does not cover a broad area. The beam is only a few centimeters wide, so the sending and receiving equipment must be aligned precisely to ensure that the sender's beam hits the sensor in the receiver. This type of transmission media is suitable for use indoors and can span great distances. As a result, laser technology is especially useful in cities to transmit from building to building. The term unguided characterizes communication technologies through free space where no wires or cables are needed. The most common form of unguided communication uses radio frequency. Radio frequency has distinctive advantage over light because it can travel long distances and can penetrate solid objects such as buildings and walls. The exact properties of this electromagnetic energy depend on the frequency. The amount of information an electromagnetic wave can represent depends on the wave's frequency, and the frequency of an electromagnetic wave determines how the wave propagates. The table describes three broad types of propagation, or moves through free space. First is low frequencies, where the electromagnetic radiation follows the Earth's surface, which means if the terrain is relatively flat, it will be possible to place a receiver beyond the horizon from a transmitter. With medium frequencies, a transmitter and a receiver can be further apart because the signal can bounce off ionosphere, hard for me to say sometimes, to travel between the two devices. High-frequency radio transmission behaves like light. The signal propagates in a straight line from the transmitter to the receiver, and the path must be free from obstructions. Low frequencies. The electromagnetic radiation follows the Earth's surface, which means if the terrain is relatively flat, it will be possible to place a receiver beyond horizon from a transmitter. AM radio broadcasting, navigational radio, beacons, and maritime ship-to-shore communication use this low frequency band. Some examples are sonar dual beam. It is 200 kHz and 83 kHz, and AM radio 500 to 1600 kHz. Medium frequencies. Since the signal can bounce off ionosphere to travel between the transmitter and receiver, these devices can be located further apart. Examples are broadcasting stations, aviation communication, government time stations, weather stations, and amateur radio and citizens band services. High frequencies behave like light, and the signal propagates in a straight line from transmitter to receiver, so the path must be free from obstructions. U.S. television channels use between 54 and 890 MHz, and UHF band dB 50 to 40 MHz. Wireless technologies fall into two broad categories as follows. Terrestrial, where communication uses equipment such as radio or microwave transmitters that is relatively close to the Earth's surface. Typical locations for antennas or other equipment include the tops of hills, man-made towers, and tall buildings. Non-terrestrial is where some of the equipment used in communication is outside the Earth's atmosphere. For example, a satellite in orbit around the Earth. Frequency and amount of power used can affect the speed at which the data can be sent, the maximum distance over which communication occurs, and other characteristics such as if the signal can penetrate a solid object. Arthur C. Clarke, who was born in 1917 but passed away in 2008, proposed a satellite communication system in 1945. There are currently about 5,700 active satellites, both government and private. Plus, there are about 13,075 that no longer work. Russia launched the first satellite, Sputnik 1, in 1957. The oldest one still in orbit, which is no longer functioning, was launched in 1958. They have a wide variety of roles. GPS satellites aid navigation. Others relay telephone or television signals. Others aid in weather forecasting, national defense, science, and agriculture, as in monitoring crops and areas of drought. The Union of Concerned Scientists, a private organization that maintains a database of satellites, says about 60% are used for communications. Who owns them? Well, governments, large and small, and private companies. More than 50 countries own a satellite or a significant share in one, according to the Union of Concerned Scientists. There are 502 active satellites with a U.S. tie, 118 for Russia, and 116 for China. Thailand has 4 satellites and shares in another. the scientist group reports. What happens when they stop working? Old satellites can pose a risk for collision with active ones, so that they have rules and recommendations to avoid a buildup of junk out in outer space. Satellites that fly below a certain height are supposed to be put in an orbit that will make them fall to Earth and burn up within 25 years. At high altitudes, they are to be boosted up to still higher orbits to get them out of the way. The advantage of a satellite in geostationary Earth orbit, GEO, is that the orbital period is exactly the same as the rate at which the Earth rotates. If positioned above the equator, a geosatellite remains in exactly the same location over the Earth's surface at all times. A stationary satellite position means that once a ground station are aligned with the satellite, and the equipment never needs to be moved. The disadvantage is that there is a delay of approximately 0.2 seconds that can be significant for some applications. For electronic transactions such as a stock exchange offering a limited set of bonds, delaying an offer by 0.2 seconds may mean the difference between a successful and unsuccessful offer. Without further refinements, the entire 360-degree circle above the equator can hold 45 to 90 satellites. Low Earth orbit LEO satellites are defined as having altitudes up to 2,000 kilometers. As a practical matter, a satellite must be placed above the fringe of the atmosphere to avoid the drag produced by encountering gases. Thus, LEO satellites are typically placed at altitudes of 500 to 600 kilometers or higher. LEO offers the advantage of the short delays, typically 1 to 4 microseconds. The disadvantage of LEO is that the orbit of a satellite does not match the rotation of the Earth, and from an observer's point of view on Earth, an LEO satellite appears to move across the sky. This also means that the ground station must have an antenna that can rotate to track the satellite. Tracking is difficult because satellites move rapidly. The lowest altitude satellites orbit the Earth in approximately 90 minutes, while LEOs at higher altitudes require several hours to orbit the Earth. LEO satellites are used in clustering or in an array deployment. A large group of LEO satellites are designed to work together. A satellite in the group can also communicate with other satellites in the group. Members of the group stay in communication and agree to forward messages as needed. For example, consider what happens when a user in Canada sends a message to a user in Europe. A ground station in Canada transmits the message to the satellite currently overhead, above it. The cluster of satellites communicate to forward the message to the satellite in the cluster that is currently over a ground station in Europe. Finally, the satellite currently over Europe transmits the message to a ground station. Low Earth between 539 to 543 kilometers, or 335 to 337 miles. The orbit of the Hubble telescope's orbit is expected to decay between the years 2030 and 2040. The choice of medium is complex. Choice involves the evaluation of multiple factors such as cost, like the materials, installation, operation, and maintenance, the data rate, the number of bits per second that can be sent, the delay, the time required for signal propagation or processing, the effect on the signal, the attenuation or distortion, the environment. Talk about the susceptibility to interference and electrical noise, and the security, the susceptibility to eavesdropping. In summary, we've talked about the types of paths, energy forms, noise, electrical energy, infrared, point-to-point lasers, and satellites.